I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the catch-all filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the see all sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information by downloading Bulletin 40-10 from Sporlan.com with all the catch-all filter dryer information. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. What do you got going on this week, Kevin?
Well, this week I'm just running around like an idiot, just trying to button up a bunch of jobs and trying not to die in Chicago when it's 103 degrees. And it's not that hot out here usually, so everything's on fire, everything's burning. Every store might as well be on fire. We're like above design ambient pretty much for just about everything, and it's pretty miserable right now. I don't know how you do it.
How hot is it there right now?
Today the high was 80. This is the first time it's been below 90 in like a week and a half. We don't get days like that. Like we don't get days where it's like 90 for like 2 weeks straight. Like that doesn't happen up here. We may get like a couple 90-degree days here and there, then it's back down to the 80s. I mean, for it to stay 90 and get to 100 as long as it has, and the humidity's been like absolutely miserable, it's been pretty brutal. I cannot wait for fall.
Well, that's the other thing too, right? You got city heat going on right now, right? So basically, the heat's just exacerbated. So
yeah, and it makes the city smelly more.
If anyone's never worked in a city like New York or like Jersey City or any of the big cities, like it just when it gets that hot is just unbearably just rotten. Everything smells like trash. And it's absolutely horrible. I am at home this week doing conference calls and finishing up some other training stuff. And then next week I'm heading out to Houston. I think I'm leaving Monday night because Monday I guess is Labor Day. Yeah.
Oh, so you've been sitting in the air conditioning for a week. That's nice.
I went on. Okay, I lie. I went out for a little bit. So we had a controller that lost its program, and I gave someone a thumb drive with the program. I fortunately had the program on there, and the controller just gave him the big middle finger and was like, nope, we're not. There's nothing on there. I had to try to rename it. If anyone's familiar, the E2s, E2Es usually have a thumb drive in the back access that you can stick a thumb drive in the back. The typical file when you save it to your computer using Ultrasight is a 003 file. When you save it from the thumb drive, it's E2B. It stands for easy to boot. Well, I guess Kevin had informed me that there are some versions of firmware where, it doesn't really work all that well sometimes. And that's what we had. So I had to go down and basically load the software onto that controller. So, but hey guys,
tonight that's super disappointing when it does that.
So tonight we're gonna cover communication issues. guys have been asking for communication and control stuff, and it's just, man, it's summertime, and it's hard enough just trying to work our schedules together to record and get some good quality stuff out. So I promise the control stuff is coming, but we're going to start off by doing some of the communication stuff first. Communication issues. It's a lot of common sense, really. Sometimes it's trying to figure out, what's taking out, a whole entire communication loop. Sometimes it's easy. Maybe it's just, a controller is just bad. But when you have, some sort of, controller that's causing, the whole comm loop to go down, or you're having wiring issues, where, maybe you have mice in the system, in the store where it's basically, gnawing on the wires and shorting out a whole system. Sometimes it's just process of elimination. A lot of helpful things is always getting the as-builts. As-builts are basically just plans of how the wiring should be. Now, you talk to Kevin, and I'm pretty sure he's going to tell you that a lot of the as-builts he's been getting here of late. What's that?
As-builts, according to the last 5 electricians I've worked with, as-builts are just suggestions. So they just pull the comm loop however is easiest for them.
Which is horrible because they don't know the ins and outs of the controllers, right? There's, you got the S3C. When we talked to Jim Jensen, he told us, we can only have 38 controllers on that loop, right? And a total max of, I think it was 328 feet of Ethernet cable. So if the electrician's just going to take that as a suggestion, guess what? He could have more controllers on the loop than the way he's supposed to. Could have wire lengths longer than what it should be, and basically you could potentially cause issues where it's dropping down the network intermittently because basically the electrician or whoever EMS guy whoever ran the wrong wire, ran too far of length, put too many controllers on the system, whatever have you. You know what I mean? Doing construction EMS stuff or any kind of demo stuff, like if they're doing a remodel, is always just fun because there's people that are cutting wires and all kinds of other stuff.
It's the absolute worst. It's not fun. What are you talking about? Don't church it up. Like when they start removing cases and everything else, it is horrible. Especially when you get some electrician that's got his dick beaters in there and he's over there cutting wires, and next thing you know, you got 4 different comm loops mixed up, and next thing you know, the E2's just turning on and off 40 times till it loses this program.
Well,
or somehow they tie 2 different E2s together. Fun fact: if you do that, you tie 2 different E2s together, it reboots until it loses its program.
Really?
Yes.
So they had 2 different comm loops that went into the general same area, and they hooked up the comm loops together, and it just kept pulling the system down.
Yeah, it was a store where they had A and B rack frozen food. They had ice cream in A rack, and they had frozen food in B rack. They were butted up back to each other. Well, we pulled out both lineups, and this old man electrician was over there. And he didn't want to listen to me because he knew better because he had 30 years experience, my favorite thing. And he was splicing the comm loops back in, and all of a sudden they walk out there and he's like, "There's nothing in that controller, kid." I'm like, oh, okay. I walk out there and I'm like, "Oh, that's cool. The one controller is completely blank, rebooted." I'm looking, can't find it, can't figure it out. Like 2 hours later, I realized that I'm looking at the wires. I'm like, holy shit, they tied both comm lines together. Turns out that'll make it lose a program at 2 a.m.
That's amazing. And trying to get a hold of the certain tech support that you need to get the program reloaded at 2 o'clock in the morning usually doesn't fare well.
That's why you always back it up.
Absolutely. So you have to be aware that, it's there is voltages given off on a lot of different comm loops. IONet, BACnet, there's usually a voltage not only given out from the controller, but also all the IO boards and stuff that's actually on the loop. So that's why you can have stuff shorted on a case controller. And I know we talked about this before, where basically you can have I've seen this happen with a 678, where basically the bipolar stepper motor basically shorts out, and then the voltage from the case controller actually ends up going through the comm loop and taking out the PIB board on the E2. And there is
had a 679 do it
really
at a store on Friday. It burned out the comm loop. It burned out a resistor on the board. It threw it was on the LAN side. It threw it through the LAN on the first through C, B, and A, and then it went from the LAN port to the mod bus. It blew up 3 more controllers, and then it took out the PIB card on the E2.
So the difference between the 678 and the 679, 678 is the bipolar stepper motor version, and the 679 is the pulse width modulation. So, you're only dealing with the bipolar stepper motor. You're only dealing with 12 to 18 volts DC. You're dealing with potentially usually 120 is that's what they're using for the coils.
It put 120. It put 120 in the loop. it literally, when the fitter that was there, because I had left for the week, he kept telling me the comm line was shocking him, and I'm like, I don't know what you're talking about. Quit being a pussy. I go, it's like 2 volts. He's like, no, it's shocking me. I'm like, okay. And then he's like, I dropped it, and it arced against the case. And he's like, there's like 93 volts on the comm loop. I'm like, oh.
That's new.
I go, well, it's Friday, so there's no food in that store, so we'll just deal with that on Monday.
Gotcha. No, so the like I said, the case controllers are and the IO boards are all putting out voltage. And the board's putting out voltage, so you can have stuff that's shorted and basically cause it to take down the loop. Most of the time, they're supposed to just start one line from the controller, whether it be Danfoss or CPC, and basically run out to the first controller and daisy chain all the way out. Sometimes some stores, they decide to make the controller actually the center of the loop. And when that happens, you don't know which comm loop that's, hooked up to that same port is actually pulling down the network. So that's where I said, the process of elimination comes in hand, right? So basically you disconnect, if the comm loop keeps dropping in and out, basically pull off both wires and then connect one at a time and see which, if the boards stay online that are connected to one set of comm loop, and then you'll be able to trace it out with the as-builts and basically try to figure out where that comm loop goes, so you can actually trace it out to see if you have some sort of short. The only easiest way I know to actually check for a short in the communication loop is finding where all the case controllers are, pulling all the wires off of the case controller, like pulling the Molex plug right off the side there, and basically measuring the resistance from each leg to ground, then also measuring each leg to itself, and then that at least will tell you if you have anything shorted together. And that's where I said before, you can have mice that chew through lines. Someone when they were pulling the wire, it had a little cut in there, and after a little bit of year, it just ended up degrading, and then end up shorting out. And then the final check for the wire integrity is basically at the end of the loop, wire all the 3 legs together, and basically you should have even ohms, right? Because basically if you're running 100 feet worth of wire, and it's like 1 ohm per 30 foot, basically each side should add up to let's just say 84 ohms on each side. If it does not, then that you have some kind of crappy connection. But that's not going to cause a shorted connection, but that is going to cause controllers to intermittently cut in and out. It gets really complicated when you have multiple comm loops that are all connected up. Some older Walmart stores that have the XR75s, they all speak on echelon, and they use what are called repeaters. So usually the E2 just has one echelon port on there, and basically it goes out to you're giving me a look. Go ahead.
Are you talking about the old school controllers?
Yeah.
Or are you talking the Dixel XR670.
No, just the 75s. The one it had a display right on the top, and it basically just reported the temperature back.
Oh, yeah, the blue Dixels.
No.
You talk about the green control links?
Yeah. So that's not that wasn't the part number.
No.
Now you're gonna make me look it up. But some of those controllers, like I said, they speak on echelon, and basically they use a repeater. So you don't have to have one whole comm loop that might be 300 foot, and that way you can basically split up the communication loop. Going over to these set of cases, these set of cases, and these set of cases. It's basically almost like a little router, but it's called a repeater. You can have those connected all up together, especially if the E2s are speaking still on echelon. We had a store where the store had five E2s, and all 5 E2s just kept turning off and rebooting, every single one. So this was up in Oklahoma, and I happened to be going up there the next day, but I just decided, to go up that night because the whole store was down. They were getting told they were going to have to run Ethernet wire to all the controllers and get them communicating that way. So basically all I had them do is, doing process of elimination, basically, disconnecting every single echelon cable going out to every single, comm loop, and basically plug in one and see if the case controller reset. Didn't do it, and then just keep going and going and going. And then finally they found, the last one they plugged in, it caused everything to reset again. So we knew at that point that on that communication loop, we basically had a short somewhere. And at that point, we had to, either find the as-built or just look in the, in the network status to see what controllers are offline, and basically try to trace out, hypothetically where it might go if we can't find the as-builts. And what had happened was we traced it back to, they usually have some deli cases in the front, and then it goes over the bakery. Well, that line that went underground, same thing with the refrigeration lines, they were chewed through probably about 6 inches by a bunch of mice, and that's what, ended up taking out all the communication loops.
Yeah. Echelon is the worst communication protocol ever.
Why don't you like it?
It is the most difficult to troubleshoot.
Yeah, because, well, see, we were talking about voltages before, right? And in echelon, there's no voltages that you can check. It would actually have to be done, from my understanding, with an oscilloscope, which I still don't have, and I don't intend to purchase one.
Yeah, I mean, yeah. So we were talking about comm voltages and splitting the network. Um, that's generally what I try to get guys to do. Um, is I start them having to split the network. So like when I'm dealing with it and I'm having the comm issues. So the first thing I do if everything's offline, I'll pull. I'll look at it from this way. We'll start with CPC. Um, I will generally start at the controller and I'll see what's offline and what COM ports are down, and then I will generally unplug um, the main board, the PIB board. So in the E2 they call it the PIB board. That's where your COM ports and power are. So what you're going to want to do is you're going to want to unplug whatever COM port you're having an issue on. You want to check your voltages coming out of the board itself. So me and Brian are getting more into this voltage thing later on. We're kind of getting down some of the base for this. And then if you have decent COM voltages coming out of your PIB board, what you're going to want to go to next is you're going to want to check it on the wires with it unplugged from the PIB board. Okay. And if I have really bad COM voltages on the wires from the PIB board, what I start doing is I start splitting up the network. If it's one wire, I go about this differently. If I have multiple wires coming off of that one port, I will split them up and plug them in one at a time, see if I can get them on. So if you plug the first one and the comm line comes on, those boards all come on. Okay, that one's good. Then I'll plug in the next one. If that one comes on and everything comes on that one, cool. Then I'll plug in the third one. If I plug a third one in, everything goes down. Now I know I got to start looking at that one. I'll start looking at the boards on that one. A lot of comm troubleshooting is like visual, like Brett said, just paying attention to what's around you, looking for burnt boards, water damage boards. Water damage is a huge thing, especially in case controllers. I think I find more water damage case controllers than anything in intermittent comm stuff. Um, and then just looking for loose wires. But I'm gonna tell you right now, 90% of comm failures are not from loose wires, like guys write up. I mean, if you're getting intermittent comm failures, another thing to check, like with CPC, you can go to that board and hit expanded information, and you could see how many errors it's had over time, how many failed to transmits, how many failed to receives. If you have a board, if it's just one board with a massive amount of errors over time, then that board could be intermittently failing. You know, it could have good voltages when you test it and all that stuff, but it could be intermittently failing. Go ahead, Brett.
Well, I was going to ask you, just explain where that is in the menu, right? So they know.
So if you hit Alt and then you go to N, you bring up the network screen. So Alt N, and you can go to the any board, and you could see. You just hit expanded information. You could see how many failures it's had.
Yeah, on some different controllers, right? They have like a Novar, they call them coefficient failures, and you'll see the numbers rise. Unfortunately, with Novar, though, you have to have someone with higher access to basically clear it. A lot of times, like if I see a store that has a lot of communication issues, and if I suspect that, hey, I think I got it, I'll basically have them clear all the coefficient failures. Basically, that the amount of times it's failed to transmit and receive. And once that cleared, I can go back the following day and see if there's anything else that might be, maybe I didn't get to the root cause. Maybe I found a star configuration in one thing. I cleared that up. I found a wire that basically went to nowhere, cleared that out. All right, let's see if that fixes it. Clear the coefficient failures, come back tomorrow and see what it looks like.
So Novar starts counting up in the amount of seconds in time that the board's in comm loss on the older legacy Novar stuff, which is actually nice because you see that on the newer Slopus junk. Don't laugh. I will never say anything positive about that thing. I mean, I have never wanted to smash my head against a controller more than that thing, but I mean you just get a network down thing, and it doesn't tell you how long it's been down, how many seconds, which just makes it kind of difficult to troubleshoot. But that's if the screen works half the time.
I've never found one that hasn't not worked.
Oh my god, there's so many of them.
Unless we're talking Comtrol.
I have a screen in my van that I could plug into those things because there's so many that are messed up in Chicago.
What, the Comtrol?
No, the Opus controllers. They're like a ticking time bomb, and they're failing like crazy.
Are you talking about the new ones, the 25s?
No, the older Opuses.
Oh, okay. Huh. Maybe because it's 120 in Chicago.
Well, yeah. You conveniently have to change out the entire controller.
Do you really?
Oh yeah.
And I found this out a couple months ago that just because it's a whatever controller, there are different versions of that.
You can't just take an XEM20 that I had sitting in my van that we ripped out of another store. I can't just take it to the store down the road that lost the controller because there's no licenses in that controller for what they have there. And they refuse to put the licenses in there. So you can just throw away all the food because you're going to throw away all the food before you get those licenses.
Oh, it'll run and fail safe.
Till everything ices up and yeah.
Well, it only takes 2-3 weeks to get a controller if they have one, right? So
I could rip one out and just put an E2 in half that in a quarter of that time.
Yeah, so if you're not aware, you can actually do a
Layover,
yeah
overlay,
uh, from
whatever
CP
whatever you want to call it, layover, overlay.
overlay. I was like I've never heard someone call it that. No, but I've done overlays for Comtrol to Danfoss. I've done E2 to Comtrol, and I have not actually done one, but I've helped program, the E2 to Novar boards. That's why if you look at the Alt M menu, if you hold in the Alt button, hit the letter M, and I think if you scroll over, hit the F2 button twice, it'll bring you up to the communication delays, and that's why it has MOD delay, which is Modbus, and then it has NOVR, that's Novar delay, and then CMTL delay, and then IONET, and then peer-to-peer, which is Ethernet delay.
So I actually did the first CPC to Novar swap over that was not done by Emerson.
Really?
Remember when that rack house fell through the building in Chicago?
Yes.
So when Client Pros got there and we started putting in a rack house that we had at the shop that caught on fire at a Walmart that they had bought. It was a brand new rack house. It had smoke damage, so they shit canned the entire mechanicals in the store and never even got tied into at that point. So we dropped that rack house there. Well, it obviously had Novar in there, and we didn't have enough boards to get everything online. And I bought a license. They actually didn't even charge me for it because they didn't even know how to charge for it. Because nobody had ever asked them for it.
Yeah,
So
because they usually do them themselves.
they do them themselves, and it's some kind of like deal they work on with Walmart. Well, so I ended up getting a license for it, and I used all the old legacy Novar boards. You could use everything but a MinIO or a backnet board, any like compressor board, condenser board. Um, some random weird stuff with that though, with the CTs taking out the com or affecting the way it would wig out the E2 sometimes with a couple of the CTs that they got like real high amp draw, but that was like on a real early version. That it's supposedly that's fixed now, but honestly, it was cake and it worked pretty good. And then I just had one multiflex board in the entire thing and an ESR board driving CDS valves doing defrost differential because I had to make the liquid pressure regulator for the liquid header, like how Walmart uses. I had to use that as a defrost differential valve.
Get the hell out.
Oh yeah,
So they
oh yeah.
actually they had hot gas defrost for that?
So the store was hot gas defrosted. We dropped the rack in, so we had to peel off a discharge header. It was a 3-pipe store. We had to peel off the discharge header, and I used the liquid pressure header regulator as a defrost differential valve.
So it's I'm assuming so this correct me if I'm wrong. So I'm assuming it was probably maintained if it's 407 it was maintained 148 all the time, right? And then basically whenever it would go into defrost, you would, use the two pressure
No.
transducers.
So this store ran whatever it was 507. So the racks were designed for 407A. We were running 507 in there. Obviously, this whole thing was just like a make it work thing. So uh, we opened the headers between the two, piped them together, and then I used the liquid pressure regulator that would normally keep the loop at like 138 to 142. I took that, and then when I got a call for defrost, it would run it to a 20-pound diff. When it wasn't in defrost, it would force the valve wide open.
Okay. The only thing I have to say about doing any of the overlays with CPC, and that's with Comtrol or that's with Novar, it isn't just board number and point. It's using what are called pointers, which can get a little confusing if you don't know your way around. But it can be done, obviously. But back to the communication stuff.
Yeah. back to the comms. So, um, I want to go over like the different comms. So we have Modbus, which is a communication protocol. So we're going to go over all these. These are all the different communication protocols we use. Modbus, typically called Modbus RTU. It's an open protocol that a lot of manufacturers use. So Dixel is all Modbus. There's all kinds of Modbus RTU stuff, VFDs. Then you have LonWorks. LonWorks is a completely open protocol. Anybody could use LonWorks. Echelon is as long as they buy their chipset, anybody could use it. And LonWorks has a specific neuron, what they call a neuron ID. It's like a social security card number. So you can't address a board with LonWorks. You have to ping the neuron ID or type the neuron ID in. Every single board has a unique signature. LonWorks, unlike most comms, don't have any voltages on the network. So a lot of times you have to ohm out comm lines. Like for example, microthermal wants a 59 ohm resistor on the loop. You should have 59 ohms from the beginning of the loop to the end of the loop. That's what they're looking for. LonWorks is specific on the type of wire you could use. It has to be unshielded cable, and generally it's a certain twist per inch, and it's a certain gauge cable, like
18.
microthermal 16 actually.
I just looked at all right, because I just looked up the spec for that job that I did, and it was echelon cable. It was 18 gauge wire for that particular.
If that was CPC, then that they're like that. Microthermal is, they say 18s or 16s, but I mean, if you want a good quality network, it's been 16s here lately, which is what I've been pulling. Depends on the customer. So LonWorks is the most detrimental around electronics, VFDs, 460. You want to keep everything away from it. That's for all comm stuff, but LonWorks even more. LonWorks is specifically has noise issues. So, and you could have all kinds of weird issues with LonWorks if you don't have that. Like Brett said, you need a oscilloscope.
And that's because the wire's not shielded, right?
So they say to not shield the wire because it picks up more noise. That's why they don't shield the wire. Because a shielded wire, the shield actually picks up noise, and then it grounds it to ground. It takes the shield and it's supposed to direct that down there, but apparently on LonWorks it causes more problems than it solves. So that's why everybody says to use unshielded cable, I guess. So then we have every control system pretty much has their own perpetual comm system. Like CPC or Emerson has IO network. That's their comm loop. That's their like board design. Like that's all their stuff. Just like Danfoss has TP87, and then they have the RS485.
Is it Lawn 78? Is that what it is?
Yeah, TP78. I mean, yeah, it's TP78.
So go ahead.
Go ahead.
No, what I was going to say is
then,
on Danfoss, they have, like you said, the 45 and the Echelon. Echelon is typically used for the, or the TP78 is usually used for the, all the IO boards, all the inputs and output boards. The 45 that's on the boards, typically there's only one port, and that's usually used to communicate from controller to controller. Now, if you do, sometimes you use things differently. So like when you do like an overlay for a control to like a 255, you actually utilize the 45 port for all the control boards, and then basically use a Ethernet hub, to basically, link all the controllers together, which I actually like better. Because when you do that, you can actually look at, if you're on rack A, you can typically look at rack C or B, or if you're at a logger in the front of the store by the manager's office, you can basically look at that, look at all the controllers before you even roll back to the machine room. On a lot of these networks, there's always usually a terminating resistor, and it's always different. Resistors aren't just, all the resistors used in communication loops aren't like typical tolerance resistors. They're typically what are called precision resistors. On a typical resistor, you can have 10%, 5% error in the reading. But usually, a precision resistor is, I think, less than 1% off of what it's supposed to be. Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry. Repairing refrigeration lighting can be performed quickly and profitably by utilizing the Luminosity Kensington Refrigeration LED. Kensington was developed by the supermarket refrigeration community to be a near universal solution for refrigeration lighting repairs. At Luminosity, we saw the frustration of technicians making multiple trips to the store sites to determine the correct parts. Labor pileups, dispatch remains open for months, high prices for the replacement parts by the OEM, and customers refusing to pay for all this effort, leading to unbillable or end-of-life invoices. Our goal was to develop the Swiss Army knife LED that technicians can carry on their trucks or at their shops to provide a one-and-done lighting repairs at a profit. Once your customers experience the clean, bright Kensington LED, they will be asking for more and making you more profits. The Kensington LED features secure metal mounting bracket for an internal driver, near universal solution for reach-in doors and air cases, walk-in and prep rooms, one-and-done repairs, easy and labor efficient to install. They have a built-in LED driver that has a universal 120 to 277 volt input, easy and secure mounting, HVAC and refrigeration contractors in the United States. They're made for damp locations, rated IP44. They have a 7-year warranty, available in 4, 5, and 6 foot lengths, and they're tested in all major brands of refrigeration units. They're also utilized by most of the major. For information and pricing, please contact Pete Murata at Luminosity. His email is Pete, P-E-T-E, at I-LUMINOSITY.com. His cell phone number is 209-814-8129. Check out Kensington Refrigeration LED and our full line of quality products at www.iluminosity.com. That's www.I-LUMINOSITY.com. Thanks for listening, guys.
Right on. And then lastly, we have BACnet, which just about everything is going to BACnet right now. So, like Walmart made this big push a couple years ago. They wanted everything BACnet. BACnet is what they call engineers protocol. Like it's a big building protocol for like HVAC stuff. Just about everything can be BACnet. It is a basically group of points you could read and write to. A lot like Modbus. It's an RS-485 protocol, so it is COM voltages. It's why you see like everything in Walmart now is BACnet. Whether it's Novar, whether it's Sporland talking to Novar, that's all BACnet. So what they're doing with that is CPC can even do BACnet. I mean, they have tons of BACnet stuff. Your Linux rooftop stuff, carrier rooftop stuff. Everything's about integration now. They're trying to push all these control systems to integrate to each other. And I mean, they're trying to make it so everything can talk to each other. So they could take this case lineup and make it SC3s, this case lineup and make it Dixel stuff, this case lineup over here with this controller. They want everything to be open protocols, which is where all these control systems are fighting each other right now, because none of them wanted to be open protocols because they all want to sell their boards and their hardware. Well, now they're not. They're just selling the front end. So that's why you see this big push to BACnet, because it's a group of points and they have to follow a standard so everybody could read and write to these points that does BACnet controls.
Not just that, but they want, we're used to, like bullseye stores, they have ALC, for their communication for their HVAC, and what I've seen usually, Emerson for their refrigeration, and now everyone's trying to get, why should I have two different systems? Why am I paying for two different systems? Everything should be, basically integrated with each other. You know what I mean? That's what that's why they're trying to do that. That's why you can have, like you stated before about the, BACnet being controlled through E2 for the Linux stuff or the carrier stuff.
Yeah, everything's going to open protocols. I mean, we're light years behind the HVAC side. I mean, they're to the point where you could have a Linux rooftop on a train control system that's controlled by or accessed by Metasys. I mean, they're light years ahead of us on graphics and stuff. I mean, most of our stuff is done as cheaply as possible on our end, so we get the crappy graphics and the brick controllers. So, but I mean, that's a customer driven thing. But that's going to be changing soon. I think it's just everybody's being pushed to integrate.
So in all these different protocols, that everyone has their own little niche, right? Echelon, I don't believe there's not different baud rates on Echelon, correct?
I don't think so.
But like on back, okay, but on BACnet, Modbus, IONet, everything basically is, has its own baud rate. What baud rate is basically the speed at which it's communicating. So if you have one controller communicating at 9600 where it's talking normal, and then you have another one controlling at 115.2 kbaud, and it's talking like the micro machine guy, so you can understand it. So the two systems can't basically understand, and basically drops information, drops segments of important information going back and forth, and that's why you have to make sure all the controllers, as well as the main system that you're working on, is all set, for that loop, for for the same baud rate. And there is stuff that can't communicate on certain baud rate, right? Any DXL product, you can change the baud rate on those. Usually they should typically be set up for about 115.2 because they're transmitting so much data, back and forth. The percentage of the valve, all the superheat settings, where the valve is, and all that other stuff. Where the IONet boards, aren't really passing a bunch of information. So, putting that 9600 isn't a real big deal. But then, you might have case controllers that are on Modbus, and then maybe you have the core sense modules that you have, communicated to, the E2. And basically, if, you might not be able to put those on the same COM port, because, if the case controllers are speaking 115, maybe those core sense modules have to be at 9600, and you basically can't have those two intertwined because they're talking at a different speed.
So with some of that stuff, I generally try to run everything in 19.2. Even like the Dixel stuff, I find those case controllers work better at 19.2. Emerson says 9600 sometimes, and then some stores you see them at 19.2. I run my stores at 19.2, and then same thing with all the Copeland stuff. It seems to mesh up a lot better. Like I've never had problems running at 19.2 until you get to CoreLink.
I think there's a bunch of people that have issues with CoreLink. Yeah, like even RDM, which can integrate with just about anything. There's only certain ways that you can communicate with it, and yeah. Although, be it the fact that RDM is like basically like a web based controller, a lot of the CoreLink controllers have their own HTTP address, so you can put it in there and basically bring it up on the RDM. I've done that before, plugged in the computer to it.
So RDM is the closest we get to a building controller. I mean, RDM is probably the most open protocol controller there is. I'm pretty sure it could do everything. I mean, those guys have told me they can make it talk to CPC boards that they want.
Mhm.
I don't think Emerson would allow that or like that, but they can do it. Um, I'm pretty sure they could do just about everything. They could probably even do Danfoss if they wanted to.
Well, the one store I saw him talking to, I believe an ALC board, and then another store I saw him talking to the same store. They were talking to a Core Link, and then that, they had it talking to their RDM controllers, and, they had probably like 5 or 6 different controllers that they were actually talking to. And I believe they can actually also communicate to the Linux stuff. The pro, is that
I literally think they can do anything. Like
product?
that controller has every single communication protocol in it.
Wow.
Like even Ethernet. Like it literally has every single communication protocol in that controller.
And CPC has it may not necessarily be in the options, but there is a list of licenses that you can buy. When you have a controller coming out the gate, an RX 400, it has the capability to talk to an S3C, but you have to buy the license for that. They also, if they, from my understanding, if they have a customer that has a special need, that's something they wanted integrated, they have guys out there that will actually, learn the protocol that is communicating with, and kind of, mesh it in with the E2 and actually build a license for it, so they're able to do that.
Allegedly.
I've seen it.
It's very, very rough in the beginning.
I'm not saying it's not rough. I'm just saying it's feasible.
Yeah, it's let me tell you this, Emerson is damn proud of their licenses too.
Yeah.
They really get you with those ones. those add up quick. But no, like Brett said, you can get licenses for just about anything. So that's why all these communication protocols are coming in. Same with RDM. They're newer to the US. You're gonna start seeing them a lot more, I think. They're all over Texas now. Up here, I think Fresh Time's the only one that uses RDM.
And they have some smaller like convenience store stuff that they were telling us when we went to training for it. But yeah, like you said, like everything HVAC base is, they use what are called Jace controllers, which is a controller that can talk to just about anything. Because like you said, it's in the way open protocol that it can communicate. Back to communication stuff, just making sure that you guys are aware. I touched on the termination resistors lightly, but you have to go by the wiring standard per the manufacturer. Per the best wiring practices. I know Microthermal has their best wiring practices. Where it actually breaks down what wire you need, what the resistance should be, and so on and so forth. Also, CPC does have one as well. I believe there's one for Danfoss, but I haven't looked at it for a minute because I haven't worked on a Danfoss controller in a minute. But you have to make sure that the terminating resistor is the exact one. They're on ALC. They, on their older boards, they would use a regular 120 ohm precision resistor. And now with their newer boards, there's usually a four port prong plug. It looks like it's the same plug that they use on the back of the MPAS variable speed evaporator fan motors. That's what it looks like. But basically, there's a plug-in resistor. The only bear about that is if the controller has lost power, because it's a power-based chip, it actually looks like, they refer to it as a SpongeBob, because that's exactly what it looks like. It's basically a small rectangle board that has orange shrink wrap on it, and it literally looks like SpongeBob SquarePants. But if that board is not lit off, you lost an evaporator fan motor, or the unit lost power, that one board not having the terminating resistor on that loop could potentially cause the whole loop to go down, or the whole loop to have intermittent communication issues. And like on something like CPC, anything on the IONet, Usually you have the terminating jumpers on there that tells you, how to terminate it, how to not terminate it. Anything that's Modbus for CPC uses also a precision resistor as well. And there's different nuances to everything. I mean, with the Modbus stuff, usually like the IONet stuff, if black is your positive, red is your negative, and then shield is the shield part, right? The silver. You go like for like, right? On Modbus stuff, typically they have you actually reverse. They basically invert the wires. So if the positive was black, then basically your negative on your case controllers are going to be black.
So just about any time with Emerson, just about, not every single time, but anytime you're doing a third-party controller, whether it be a Nidec drive, Danfoss drive, any kind of third-party Dixel, KE2, that stuff, you're going to want to invert the comm loop. So you want to invert it at the controller. Do not do it at the cases.
Why?
Because that becomes confusing.
To who?
So to somebody who has to come back and troubleshoot it later. So you're going to want to invert the comm. Novar is the same way with a lot of stuff. Novar, some certain boards like black label and white label min IOs. I think the black label min IOs have to have the comm line inverted. If you're on legacy Novar, if you were a white label min IO, would be the same as the Spectrum boards. So that's why certain boards that you got to really pay attention. Certain boards you may need to invert the comm line on, and it'll tell you, in there what happens. All Modbus Dixel stuff with a need to, you have to invert the comm line. All Nidec drives, same way. So black would be positive, or if you're at Walmart, white and black white is positive, black is negative. You're going to invert it still. So that's one thing to really look out for is when you invert the comm. And then second thing I want to talk about is transformer voltages. Huge missed problem. So make sure transformers are tapped properly. If you have a 208 rack, it's probably got to come out tap 240. So if you got 205 volts, 200 volts, and you're tapped for 240, you may only be getting 18 volts at the transformer, 17 volts. Well, that may intermittently drop down when it's 100 degrees in Chicago or Texas, and everybody's running their air conditioning and the power grid really sucks and they're getting real low voltages. Well, now it's going to be a real big problem because say it gets down to 198. Well, now you're dropping to 15, 16 volts. And now you got comm boards dropping out randomly. Time you get there, it's cooled off a little bit. And next thing you know, the voltage is back up and your voltage, you got 21, 22 volts. You think it's fine. So that's another big thing to check. I always check, make sure my transformers are tapped properly. And then let's talk about center tap transformers. So some boards require center tap transformers. A center tap transformer is basically where they tap the middle windings. And then they're getting 12 volts out of it. So from the hot to the center tap, you get 12 volts. From the common to the center tap, you get 12 volts. And across the transformer, you get 24. So like Emerson, all boards that do one function need to be tapped. It's the easiest way to remember this. So any board that performs one function, whether it's an output board, an input board, an ESR board, those boards all do one thing. They need to be center tapped. If a board does multiple things, like a multiplex board, it does not need to be center tapped. That is the easiest way to remember that.
Also make sure that, even though the schedule or whatever says that, it's supposed to be, an X, a 240 volt transformer or whatever, just verify that. I've had a couple of new racks come out of a certain manufacturer where, they said they were supposed to be a dual tap, 208, 240, and they weren't. They were basically only 240. So same instance that Kevin was just talking about, it would run fine all day long, and around anywhere from 2 to 4 o'clock, the highest part of the day, basically voltage would drop down. We get the call again. Guy would go later that night where it would cool off, no problem. Then we get the call again the next day because it was just an intermittent voltage issue. And that transformer thing is a really good thing to remember, especially even doing with rooftop units. I know we're dealing with comm, but just to put it out there, when you guys are dealing with, HVAC issues, one of the first things you check is the transformer tapping, because those things are slammed in there really fast, not really done an efficient startup. Always check transformers on anything just to make sure you don't have that issue, especially big cities, where you have a large draw on the grid. I remember being down in Philly, and the voltage would get down to 184. We had to end up putting phase loss monitors on a lot of the equipment, even single systems, because the grid would go down, voltage would drop down that low, and we ended up burning out 4 or 5 compressors on a facility.
Yeah, it's how like every store is in like residential areas in Chicago, where especially the older parts of the city, where they get we're only getting 208 service, not 460. It's a disaster. Like, you're lucky to get 196, 195 is pretty good in the middle of summer. They eat condenser fan motors for breakfast.
It's awesome. The VF dig that.
Oh, they love it. Love it. So that's one big thing is transformer tapping, and if we're looking at comm stuff. And then, for the love of God, if you're running a comm line or you're doing anything, label the damn wires to and from. That has got to be my biggest pet peeve with electricians, is them not labeling wires to where it goes and where it's from.
It wasn't on the spec.
I do that. Oh, the suggestion sheet. It's the suggestion sheet. Twice. So when I do my stuff, I am a Nazi about this. I want everything heat shrinked, all the comm line inch heat shrinked, but I buy the perma-sleeve wraps on the label maker roll. They're expensive, but they're worth it, because you don't got to do 2 things at once. But and I label where it came from and where it's going, so that way, the in and the out. That way I know where all the wires go, because it'll make it so much easier to troubleshoot, especially when you're splitting the network in half and you're going apart. And like when I have comm issues and we're talking about splitting the network, and you start at the beginning and you get a couple boards on, you know that the E2 is not the problem, or the controller's not the problem. You go to the first 2 boards. I split it off from there. I plug the first 2 boards in. If I get it on, or the first board, I get that one online, then I just keep going. So then I may jump 5 boards, and bite off a bunch. And if I unplug the rest of the network and get those 5 boards on, okay, then I keep going on. I just keep moving on down the line. But if I don't know where to go on the line, we got a huge problem. I'm going to be spending a bunch of time trying to figure out where this comm loop is going and tracing it out. And that's why labeling your wires and actually following the print is a great thing. But also, I don't know who some of these prints, because they're terrible.
So I'm sitting here thinking while you're talking, and you're expecting someone that can't use a broom to label wires and follow a print,
and or pick up their material or mess, or.
Well, yeah, that's what I'm saying.
I followed the broom a couple of weeks ago, and I was very concerned.
Really?
Oh yeah. I mean, I figured something bad was about to happen. If you guys don't know, electricians are probably the laziest, or not laziest, the worst at cleaning up their mess ever.
All right. Well, hey, we're going to cut it off there. We'll have more information. We'll get deeper into different manufacturers, and get you some concrete voltages and stuff in the next podcast we do. Guys, thanks a lot for listening again, and catch you next time.
Yep. Have a nice night, guys.